Okay, so today's lesson is over what's called slope and rate of change. Now, in the past few days, we've been talking about the constant of proportionality. Okay, we've used the formula y equals kx. Okay, well now, for no apparent reason, we're going to change that k into an m. And guess what? M doesn't stand for any word that starts with an M. It stands for slope.
Isn't it y equals mx plus b?
The only reason I can think of that they don't use S is because an S drawn quickly kind of looks like a 5. I don't know. But what we're really going to be getting into is we're still talking about relationships, all right? But we're going to look a lot at graphs. And if things change at a constant rate, then that line that it makes is linear. Okay? Now, even lines that are not proportional, like that one, they still have a slope. Okay? They still have a rate of change. And our rate of change is constant. All right? Basically, that line is going up at a rate that doesn't change, right? It keeps on going up at a steady pace. All right, now if we had this line, that rate of change is no longer constant. All right, it's going up slowly, and now it's going up fast. All right, and so a line that's curved like this doesn't have a slope. All right, so pretty much all that we're talking about today is lines that go up like this, straight linear lines. Okay. You're going to hear a lot about the equation for linear lines. It's called the linear equation, and you're going to hear this over and over and over until you graduate college. Y equals mx plus b. Okay? We're not going to talk about what the plus b means today. All right? But we are going to focus a lot on the m. What does m stand for? Slope. Slope, because why wouldn't it stand for slope? All right. So, when you hear the word slope, what do you think about?
Like a mountain.
Yeah, you think a hill or a mountain because you think of skiing, right? Gonna hit the slopes, okay? When we're talking about a slope, and when we go skiing, we're talking about the side of the mountain and how steep it is, right? A slope in math is the same thing. It's telling us how steep that line is going to be. Okay, so if I have that line, it has a greater slope than that line.
Wait, ow, those don't start at 0.
I thought it was steeper. Because it's a higher?
Do what?
They don't start at 0.
They don't have to start at 0. It's a straight line, right?
Yeah.
So it has a slope. I said earlier that it could do this right here. All right? And it still has a slope because it's a straight line. It's the rate of change that stays constant. Now, it has a greater slope, and I'll do it in a different color. The black line has a greater slope than the red line because it's steeper, right? That would make us ski a lot faster, okay? Now, when we're talking about slopes in regards to lines, there's a rule that we go by. We always read lines from left to right, just like you read a book. Okay? Some of you read your books right to left, and you're not very good at reading. But most of us read from left to right. We go woo do 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 do. All right? That's how we're going to read our lines. So, if I'm reading this line from left to right, is it going up or down?
Up.
It's going up. All right? Whereas this line is going down. Okay? The reason I clarify that is that because some kids will look at this line and they'll say, well, coach, that line's going down. It's only going down if you're reading the line from the wrong direction. Okay? So, if it's a line that's going up, that is a positive slope. Whereas this line is a negative slope. Okay? Now, if the line is going straight up or straight down, straight up or straight down, or left and right, it's a little bit different. All right? If we go skiing on a line that is left and right, you go skiing on that. This is West Texas skiing, okay? And you get on your skis and you got your little sticks or whatever, and you go on that hill, how fast are you going to move? You're not moving at all, right? That's because the slope of this line here is 0. It's 0. We're not moving. Okay, does that make sense? Now, what happens if you go skiing on this slope? You're going to fall and you're going to die, okay? So, because of that, this is an undefined slope. Look, it makes a little face. It's like I've done this before. All right, so slopes that go up are positive slopes. Slopes that go down are negative slopes. Slopes that are left and right, you wouldn't move, so they have a 0. Slopes that are straight up and down, you would die, so they are undefined. Okay? We'll get into classifying slopes a whole lot, but today that's not really the focus of our lesson, so we don't have to worry too much about this. All right, but I did want to intro it while I'm making this video. All right. Whoa, I don't know what I did. I did something. Okay, cool. What I really want to talk about today is how we can calculate our slope. Okay? Slope and the rate of change are terms that can be used for the same thing. They both mean the same thing. It's how our relationship is changing. Okay? If there is a slope, then the rate of change is constant. Okay? Now, just like we did with proportional relationships, we can see this in 3 different ways. And we need to be able to identify the slope in 3 different ways. We need to be able to identify it with a graph. We need to identify it with an equation. And we need to identify it with a table. Okay? We need to be prepared for all 3 of those. Okay? So, when we talk about slope, these are the terms that you're going to hear me say over and over and over. When we were solving for k, what was the formula we used for k? Y over x. Good. Okay. I told you that m is really similar to k, right? It's very, very similar. So, when we're talking about slope, it's not really y over k. It's this right here. Now, I know you are going to go, what is that?
Triangle Y, triangle.
Yeah, triangle y, triangle x. Triangle means the change in. Okay? The change in. Okay? Why? I don't know. That's just what they use. All right? I didn't make it up. All right? But the change in y over the change in x. Remember, slope and rate of change. We're talking about how the relationship is changing, right? So, I want to know about the change in y over the change in x. How much did the y change versus how much did the x change? Okay? Now, what kind of motion does y talk about in a graph? When we're talking about the y versus the x. Yeah, up and down, right? Y is our up and down. So, I'm going to go ahead and just draw that just to clarify. Y is up and down. X is left to right, right? Side to side. Okay? So, when we're looking at our line, I want to know how much it changed up and down versus how much it changed left and right. Okay? The term that you'll hear, and you'll hear this over and over and over, and I bet most of your parents probably don't remember much math, but I guarantee they remember this term here. Rise over run. Rise over run. Rise over run, when you have a graph, is how we're going to be solving for our slope. Okay? And it's the most important time to solve for slope is when we have that graph. Now, for rise over run, what I mean is how much did it go up and down over how much it went left and right. Okay, so let's say I'm going to draw a graph here.
So we are going to work with graphs today?
Mm-hmm. Let's say I had this line, okay, and I had this point and this point. These are 2 points on that line. And I want to know the slope of this line. All I would have to do is say, okay, first I need my rise. It went up so many spots. We'll say 2. And then it ran so many spots. We'll say 5. All right? So my slope for this line would be 2. over 5. That's it. How much it went up versus how much it went over. Now, in this situation, I don't have an actual graph, right? And so since I don't have an actual graph, I made those numbers up. But I can give you an example with an actual graph. Okay, let's... all right, let me go over here. Now, there's a blue line here. We're going to ignore that blue line for now. I don't know why all of that moved over with it. It's not supposed to, but okay. We're going to ignore this blue line. We're going to use my own blue line. We're going to say this and this. That's going to be my line. Let's just pretend that's a pretty line and not an ugly one, okay? Now, if this is my point here, and this is my other point there, how do I solve slope? By doing rise over run, right? Yeah. So, to get from, how do we read lines? Left to right. Good. Thank you for remembering that. We read it going this way, right?
Also be like a negative.
So, going from the left point to the right point, how much did I rise?
You didn't.
No.
What was my up and down movement?
Negative.
Down.
Negative, all right. I didn't go up, you're right. I went down, so that's a negative, but how much?
Negative 1.5. 3.
Count with me.
2.
1, 2. Negative 2. How much did I run?
Negative 3.
So that's a positive.
1, 2, 3. Your run is always going to be positive because we're always going to the right. Okay? That's why we read it left to right. Okay? So the only thing that will be negative is your rise because you might go down. Okay? Now, let me... Whoa.
Wait, so on every paper there's going to be like 2 different lines.
Whoa. Oh, I don't know what's happening. I'm losing my mind.
How did you fold that?
No, it'll be one.
All right. So, looking at this slope here, is this a positive or a negative slope?
Negative.
Positive.
Read it from left to right.
Negative.
Positive.
From left to right, is it going up or down?
It is going up.
It's going up. So that would be a positive slope. What about this one?
Negative.
Down.
That's going down. That's a negative slope.
Negative.
Negative slope.
Positive.
Positive slope. Positive slope. All right. So if you do these problems and you look at it and you have a negative answer for this, you did something wrong. Okay? Now, I can already see some of you are looking all confused because you're saying, well, that line's going down.
No, you read it left.
Yeah, it is going down if you're reading it from right to left. If you go from right down to the left, then yeah, it's going down. But if you read it from left to right, like you would read a book, it's going up. You see that? Okay. So, when we have a graph, rise over run. Does that make sense? That's the big thing. Rise over run. How much it went up versus how much it went over. If it went down, then your rise is negative. Okay? We're good? Everybody's got that? All right, sweet. Okay, so not in your homework. You are going to have homework. Go ahead and collectively, oh. Boo. Yes, okay. We got to practice this. And so, tonight in your homework, this is your homework right here. All right? You're going to give me the fraction that represents that slope. Okay? By putting rise over run.
Okay.
So you basically just did number 1. Yes, sir.
All right, so not all of them will be that way. Oh, man. All right. Now, what we have here, and I'm going to actually skip that part. I'm going to come back to it because that's the harder one. Let's look at the equations.
I never understood that.
Now, does anybody remember the equation I told you represented our lines? Y equals something.
Y plus B.
Hey, there we go. We got it. Y equals mx plus b. All right. Now, remember, we don't care about the plus b yet, right?
No.
So I'm going to ignore that. All we care about is the m. That's what it wants us to find, right? The slope. Okay. So, where is the m located in that equation?
Number 1.
In front of the x. The number in front of the x. That's your slope. So when we go through our homework tonight, and I'm going to make up some problems here. If I had y equals 3x minus 2, what's my slope?
3. That is a 3.
3. If I had y equals negative 2/3 x minus 100, what's my slope?
Negative 2/3.
Negative 2/3. All right? Yeah, it's a number in front of x. What if I did this?
So basically, we just circle it.
Here's where things get tough.
Y. 0. You have to see.
All right. If it was 0x, that would equal 0, right?
Yeah.
So it wouldn't be there. So how many x's are there?
0.
1. That's 2.
That would be 1x.
Oh, wait, what?
Okay. Y'all have learned that before, but there's been summer since then. If it's a variable by itself, then the number in front of it is an automatic 1. Okay. Now, they're not going to put a 1 there because 1 times x is just x. So they're not going to put a 1 there. So if there is no number there, your slope would be what? 1. What if it was a negative x? What would your slope be? Negative 1. Okay? That will be on your homework. Okay? So don't come up to me and go, Coach Thomas, there's no number. All right? If there's no number in front of the x, it's a 1.
Wait, so do we just write 1 or do we...
You would say 1 and circle it. It's a smoke alarm. And now I'm on the video saying, no, that's a smoke alarm. All right. So now, that's going from an equation, yes, sir?
So you said, like, how many x's there is, that's a number. Would there ever be more than 1 x there?
Well, I mean, if we have 2x, that means there's 2 x's. Okay, because it's 2 times x. All right? All right, oh, that's not what I wanted to do. All right, now, let's talk about this. This is the tougher part. Now, and I'm going to do a couple of examples for you here. All right, so you're going to want to make sure you pay attention to this, and I have it written on the board so you can copy it down here in a little bit. All right, we said that slope is solved with rise over run, okay? But what was the other thing that we used to describe slope? Anybody remember? Triangle y over triangle x. The change in y, which would be how much we move up and down, all right, versus change in x, which is how much we move left and right. What?
Isn't that part like y of 1 minus y
Yeah,
of 2? Okay.
yeah. But we're just gonna ignore that for now. Okay, so the change in y over the change of x. That's how much our y has changed over how much our x has changed. Okay, so in number 9, in this problem, we have 8, 10. Which is our x and which is our y?
A is y times x.
It's always alphabetical order. X and y. All right, because it goes X, Y, Z, right? In the alphabet. W, X, Y, Z. You know what I'm talking about? X, Y, Z. So X comes before Y, and so does it does the same thing in coordinate pairs. So I want the change in Y. I want to know how much my Y changed. Well, I went from 10 to 14. And on my X, I went from 8 to negative 7. Now, if I want to know how much it changed, I'm going to have to do some subtraction here. Okay, so I had from 14 minus 10. That'll tell me how much I changed. It would be 4, right. So my Y changed a total of 4. All right, at the bottom, this is why I want you to do the subtraction. Now we've got a negative, and you guys stink at negative numbers. All right, negative 7 minus 8. Use your calculator. Tell me what that is so you don't mess it up.
Negative 15.
Negative 15. So our slope is a negative 4 over 15. See how we did that? I had a negative in the bottom, so I just put the negative out there.
Wait, so you're just minusing those numbers?
Subtracting. Subtracting.
Oh, yeah, that.
All right, so
Wait, where'd you get 7 and 8?
8.
Oh,
All right.
like the first 2 numbers together, the last 2 numbers together?
Yeah, because we're doing the change in Y. So let's do number 11, okay? We're doing the change in Y. All right, what was my original Y? Not 4.
Hey, wait, what are we? -4?
Negative 4 was my original y. And what did it change to?
-10.
Negative 10. All right. Over the change in x. What was my original x?
-20.
And what did it change to?
-12.
All right. Y'all are going to have to do subtraction to figure out how much it changed. I'm just saying that negative 4 changed into negative 10. And negative 20 changed into negative 12. So we can do subtraction to figure out how they change. So we would say negative 10 minus negative 4.
-6.
Negative 6.
And then the next one's -8.
All right, so from negative 20 to negative 12. No, it's not. You do negative 12 minus negative 20.
Negative 32. It's gonna be a positive because the negative is negative.
It's 8. All right? Because negative 20 to negative 12, it went up, right? Negative 12 is a bigger number than negative 20.
Oh yeah.
You would rather owe me $12 than owe me $20. Okay? So, negative 6 over 8. Now, that's a good answer, but it actually reduces to negative 3 over 4. And that would be our slope.
Wait, but I'm still confused.
What?
Because, like, are you just going from the bigger number to the smaller number?
No, I'm going from the first number to the second number.
But, like,
So-
but you subtracted 10 minus 4. I thought you were supposed to do it the other
Well,
way.
because let's say let's use an easy number so you can see why I'm doing that. Let's say I went from 1 to 3, and I went from 4 to 6. Okay? How much did I change from 1 to 3? 2. You can do that in your head, right? And how much did I change from 4 to 6?
2.
I went up 2, right?
So
Okay. Now, 3 minus 1 is 2. 6 minus 4 is 2. I'm doing the subtraction by taking my original number minus that first number, all right, and it'll tell me how much I went up or down. Does that make sense?
Do we have to like simplify it at the end?
I would simplify it. All right. If I were to say, okay, your starting bank account was $113, but now your bank account
Oh dear.
is $342. How could you tell me how much money went up? You would subtract, right? I'm doing the same thing. All right? You said you would take 342 minus 113, and that would give me how much money I added to my account, right?
Well, yeah, I get that.
That's the same thing.
Wait, but you did, like, on the other one, on this one over here, you did 10 minus 4, but then you switched it around on the bottom one and you did 20 minus 12. So does it matter what
No, see, look, I went negative 4 changed into negative 10. Negative 4 changed into negative 10. Negative 20 changed into negative 12. Negative 20 changed into negative 12.
So you would just subtract from what it changed
Mhm.
first and then the original number.
You can't get confused by which is the bigger number, which is the smaller number.
Wait, so does it matter if we subtract it?
This is our starting point, right?
Yes, it does matter.
This is where we ended up.
Well, I know that, but, like, does it matter if we go, like, 20 minus 12 or 12 minus 20?
Yeah.
That's what I'm asking.
You put the bigger
Yeah, you
number
have to put the
first.
bigger number first.
No,
That's what I was...
no, you don't. Don't do that.
You put this up first.
What I'm saying is, I want to know how much I went up or down to get from negative 4 to negative 10. Okay? So, it's just like when we talked about your bank account. All right? I went from 113 to 342. So I took my new number and I subtracted my original number. So over here, I'm taking my new number and I'm subtracting my original number. I'm taking my new number minus my original. That'll tell me how much it changed.
And so on the bottom when you have to go -12 minus -20.
Exactly.
-20 minus -12.
Yeah, because if you did negative 20 minus 12, now you're going in a different direction. Okay? We take our new number minus our original number.
I thought you already did the other one.
Okay? So, let's look at this one. I went from All right, these are my x and y, x and y. All right, my change in y. That means I went from -6 and I changed to 16. Okay? And then on my change of x, I started at -19 and I changed to a +15. Now, I want to know how much they changed. So to do that, I'm going to do subtraction. This right here is not subtraction. All right. I'm just saying this is what changed into what. So to figure out how much it changed by, I'm going to say, okay, well, to get from -6 to 16, I just figure out what the difference is. So -16 minus a -6. All right. And you'll have to do that in your calculator.
It's 22.
And it's 22. So to go from -6 to 16, I went up 22. Does that make sense? Okay, so we have 22. All right, to get from -19 to 15.
-34.
All right, I do 15 minus -19. And I get I get positive, I'm sorry, +34.
Wait, so you always put the positive number? Depends on
Well, no, if it went down, it would be a negative number. All right, like up here, we went from -4 to -10. We went down. All right, so it was a negative. But down here, from -19 to 15, we went up. So it's a positive number. Okay? So 22 over 34 is an okay answer. It's not the best answer. All right? In your calculator, put 22 over 34. It's going to give you a decimal.
6.4705.
All right. So it should have given you a decimal point something, something, something. All right? Now hit math, enter, enter.
Where's that at?
Oh, I forgot how to do that.
17.
And that reduced it for you. So that's a better answer. So your calculator can reduce fractions for you.
My calculator's weird.
All right. All right, so basically, and if, whenever you take the test, whenever you take your STAR test, you have a formula chart, right? And if you go to your formula chart, and Rowdy, you pointed this out earlier, when you go to your formula chart, it'll say slope, all right? And what it'll have written is it'll say y2 minus y1 over x2 minus x1. That's what it actually says on your formula chart. So what they're saying is, when we get to that formula chart, we have our two coordinates, right? All right. This first coordinate here is our original x, our x1. Then it's our y1. Then our second x is x2, and our second y is y2. So you can see they're figuring out how much it changed from y1 to y2 by doing the subtraction. And they're figuring out how much it changed from x2 to x1 by doing the subtraction. Okay? So you're going to see that formula a lot, and you're going to get used to it. It's really not that bad, I promise. It's new right now, so some of y'all are flipping out, but I promise it's going to be okay. All right, now, what happened? All right, now, the last thing they can do to you, all right, is they can give you a table. Okay, they give you something like this, all right? By giving us this, they're giving us coordinates, right? How much did my y change? How much did my x change? That's my slope. Change in y over change of x. All right.
Wait, is it X? Wait, which one's the X? Oh, wait, never mind. I remember. And the X always goes on top.
Not always. They could put the x on the bottom. Okay. All right. Yeah, as soon as I turn this video off, I'm going to show you all a trick with your calculators too, but we'll get to that. All right. So anyway, that is our breakdown on slope. Okay. It's new. I know it's new, and it's going to feel weird at first, but I promise once you catch on, it's one of the easiest things that we do. Okay?